Hello dear students, good evening. Today is the sixth session of Vector Algebra, and today we are going to discuss vector product or a cross product. But before I proceed further, please confirm that you are able to hear my voice very clearly and able to view the screen properly. Please confirm once.
Sir.
Okay, great. Thanks for the confirmation. Okay. So, if you recall, dear students, that earlier we discussed in the very, beginning of the session of product of two vectors, we discussed that there are two types of products of vectors. One is scalar product, and that we already discussed in the previous two sessions. In this session, we are going to discuss the second type of product, and that is called the vector product or cross product of two vectors. That is the point of discussion for today. Okay. Now, before I proceed further, I just want to tell you that earlier we discussed on the three-dimensional right-handed rectangular coordinate system. So what is that? That is, three-dimensional. Okay, because there are three dimensions involved here. That is x, y, and z, right-handed and rectangular coordinate system. Okay, so what is meant by that? In this system, so when the positive x-axis, as you see here, this is the positive x-axis, is rotated counterclockwise into the positive y-axis. That means this is the positive x-axis and this is positive y-axis. When the positive x-axis is rotated counterclockwise into the towards the positive y-axis, then a right-handed screw would advance in the direction of the positive z-axis like this. I repeat once more. When the positive x-axis, what you see here, is rotated counterclockwise. Counterclockwise means it is in the opposite direction the way a clock arrow moves. Okay. Into the positive y-axis, this is positive y-axis. A right-handed screw, that is a standard screw, would advance, it will advance in the direction of the z-axis. So why the example of screw has been taken here? So if you take a screw something like this, as you see here in this example, and if you start rotating the screw in this direction, as you see here, then what you will see the tip of the screw will advance into the upward direction. Correct? I hope you got it. So that also we can explain in a right-handed coordinate system. Okay, so how we can explain in the right-handed coordinate system? So let's understand this. A right-handed coordinate system. So you take the right hand. So let us take the right hand as you see in the adjoining diagram. This is the right hand. Okay, in this right hand, okay, the thumb of the right hand, this is the thumb of the right hand, okay, points in the direction of the positive z-axis. So that the thumb is actually directed towards the positive z-axis. When the fingers, these are the fingers, right? When the fingers are curled, means are rotated in the direction away from the positive x-axis towards the positive y-axis. That means once the finger is taken away from the x-axis and moves towards the positive y-axis, then what we will see that the thumb is directed towards the positive z-axis. That is also known as the right-handed, in the right-handed coordinate system. That is the you can consider this as a right hand thumb rule. Okay, so that is very relevant in context of the discussion of the cross product or vector product. Okay, so let me explain you on this thing. So before I proceed further, So let me first define you what is the cross product definition. Let me see whether it comes into this screen or not. I want to place in this screen so that I can explain with the right-handed coordinate system. Let me see. Okay. Let me reduce little bit. Yeah, I need to reduce little bit. Yeah. Okay. So the vector product. Okay, the vector product of two non-zero vectors A and B are two non-zero vectors A and B is denoted by A cross B. As you see here, it is denoted by A cross B. So I am writing it here, A cross B. That is why it is known as a cross product. Okay, and is defined as A cross B equal to modulus of B, modulus of A into modulus of B. That means the magnitude of the vector A into magnitude of the vector B sin theta, and there is a unit vector eta. What are those? Theta is the angle between the vectors A and B, and theta is in between 0 to pi, including both 0 and pi, and eta, you see there is a cap on top of eta, is a unit vector perpendicular to both the vectors A and B. Okay, you can consider the theta as n as well. So here in this symbol it is n. Let's consider this is n. So I repeat once more, A cross B is equal to magnitude of the vector A into magnitude of the vector B into sin theta, where theta is the angle between the vectors A and B, where 0 less than equal to theta less than equal to pi, into n cap. And what is n cap? N cap is a unit vector perpendicular to both the vectors A and B. Okay, such that vector A, vector B and that n cap form a right-handed system. Okay, let us see by means of this diagram. This is the vector A, this is the vector B. Now we are going to find the cross product of these two vectors A and B. Then what it is? Modulus of the vector A, that means the magnitude of the vector A, into magnitude of the vector B, into sin theta, where theta is the angle between the vectors A and B, where 0 less than equal to theta less than equal to pi, into n cap. N cap is a unit vector perpendicular to, so I underline, n cap is a unit vector perpendicular to both A and B, such that is very important, such that A, B and N form a right-handed system. What are the right-handed system? I explained earlier, and it is there in the in the left hand side, as you see. That means what? If you move the vector from A towards B, if you move the vector from A towards B, what will happen? That that n cap will point it upward, right. So that will be the n cap will point it like this. Similarly, if you move it from B towards A, means if you move something like this, B to A, so let me use a different color. Okay, so let me use a blue color. If you move from B to A, what will happen? Then you see that n cap will be moving towards the downward. Okay, so it will be moved towards the downward, and that is why it is symbolically represented as minus n cap. Correct? So that is why it is for the right-handed system. So now if I give you it little elaborately, now if I come back to the left-hand diagram, you see, if we take the vector, this is the vector A, for example, what I am drawing in the green color. suppose this is the vector A which is along x axis. Now this is the vector B along y axis. Okay, so this is vector A and this is vector B, and the angle between A and B, in this case it is 90 degrees. Suppose this is this is the angle. Okay, then what will be the n cap vector? N cap vector will actually point towards the z axis. Okay, so n cap vector will point towards the z axis. This is the n cap vector, means this will be the n cap vector. Correct. So in this case the angle between the vectors A and B, but in general if the angle between the vectors A and B is theta, then A cross B is equal to mod A into mod B into sin theta into n cap, where n cap is the vector perpendicular to both the vectors A and B. You can say like this. Okay, where n cap is the vector perpendicular to both the vectors A and B. Also you can say that n cap is the vector perpendicular to the plane containing the vectors A and B. So that means when you have two vectors A and B, you can draw a plane containing these two vectors A and B. Now what is n cap? N cap is a vector, more precisely to say it is a unit vector perpendicular to the plane containing the vectors A and B, or you can say perpendicular to both the vectors A and B. This one, as you see in this case z. Okay, z axis is perpendicular to both x axis and y axis. Similarly, in the same context we can say that n cap, that is a unit vector, is perpendicular to both the vectors A and B. Now if either A vector is a 0 vector or B vector is a 0 vector, then theta is not defined, and in that case we can consider that A cross B is equal to 0, and it is quite obvious. You see, that is the definition of A cross B. Now if a magnitude of either A or B is 0, then this becomes 0 na? Okay, so ultimately A cross B will be 0. And another point, very important point, is that you see A cross B is equal to mod A into mod B into sin theta into n cap. Now that n cap signifies that A cross B is a vector. See, mod A is a scalar quantity because that is a value, mod B, that is also a value, sin theta, that is also a value. All these three quantities doesn't have any direction, mod A, mod B and sin theta, but n cap is a unit vector. The moment all these scalar quantities, that means mod A, mod B, sin theta, you can consider this is a real number. Now that real number is multiplied with a unit vector n cap in this case, that makes the entire thing is a vector. That means A cross B is a vector. Now here I can go back to the previous category of product, that is called the scalar product or dot product. If you recall, they are A dot B, the scalar product that generates a scalar quantity. But here in case of a vector product, that A cross B generates a vector. So that is why the cross product is known as a vector product, and earlier we discussed that dot product is known as the scalar product. I hope so far it is absolutely clear. Now let me proceed to the few observations, and these observations are very important both to understand the concepts what we have done, and also important to solve problems based on cross product. So the first observation, let me first place the note properly in front of you and then I will explain. Okay. The first observation, A cross B is a vector, and I just explained that why it is a vector, because I can tell you once more that A cross B is equal to mod A, that means magnitude of the vector A into magnitude of the vector B into sin theta, where theta is the angle between the vectors A and B, and n cap, where n cap is a unit vector perpendicular to both the vectors A and B, or you can say perpendicular to the plane containing the vectors A and B. So, A cross B is a vector. The first point is understood. Second point, let A and B be two non-zero vectors. Then A cross B will be equal to 0 if and only if A and B are parallel or collinear to each other. Very important statement. A cross B is equal to 0 if and only if A and B are parallel or collinear to each other. So, let me explain you this property. Okay, what does it mean? Now, if you go back to the definition of A cross B, that is magnitude of the mod A into mod B into sin theta. Now, when it will be 0, that will be equal to 0, means I should say literally 0 vector. So, now mod A is not equal to 0, mod B is not equal to 0, because it is given A and B are non-zero vectors, that is mentioned here, right, non-zero vectors. So, that implies sin theta equal to 0, correct or not? Now, sin theta equal to 0 means what? Now, A and B are parallel. When two vectors are parallel, then the angle between them is 0. What is theta? Theta is the angle between the vectors A and B. Now, when you say sin theta equal to 0, that means here I can say theta equal to 0. There are many values of theta for which sin theta equal to 0. In fact, it is in pi, but I am not going to that discussion. So, let us take theta equal to 0. Theta equal to 0 means the angle between these two vectors is 0, and that is possible when they are parallel. So, that is why this statement is mentioned that two vectors are parallel or collinear. When two vectors are collinear, then also they are parallel. Okay. For example, suppose this is the vector A. Okay. Suppose this is the vector A, what I have marked in the blue color. Now, suppose I have another vector B, that is the initial point and that is the terminal point, what I have marked into the in the green color. So, now here also the angle between the vectors A and B is 0. So, the vectors A and B are parallel to each other. So, A cross B is equal to 0 vector, null vector, okay, imply and implied by, that is why it is a both side arrow here, that A is parallel to the vector A is parallel to vector B. So, what does it mean? If someone is telling, hey, I have two vectors A and B such that A cross B equal to 0, then you can say, okay, then the vectors A and B are parallel. Now, some other person is telling, two vectors A and B are parallel to each other, then you can say, oh, then A cross B should be a 0 vector or null vector. Okay. I hope you got a very clear idea. Now, let me proceed to the next point. Okay. And next point, let me bring it here and then I will explain from this. So, in particular, A cross A equal to 0 and A cross minus A equal to 0, both the things, A cross A equal to 0, okay, and A cross minus A equal to 0. Why it is equal to 0? Since in the first scenario theta is equal to 0. How come theta is equal to 0 in the first case? So, let us take, there is a vector A, suppose this is a vector A. Okay. Now, we are making a cross product with the same vector, that means again the same vector A. Okay. So, what will be the angle between these two vectors? 0, that is why it is mentioned theta equal to 0. But if we take the vector minus A, So what will be the vector minus a, and if I draw minus in the blue color, so if vector a described in the red color, so vector minus a will be something like this, whatever I have mentioned in the blue color. Now see what is the angle between these two vectors a and minus a, that is actually pi. So what is mentioned here in the second case. In the second one, theta is equal to pi, making the angle, but in both the cases, whether theta equal to 0 or theta equal to pi, sine is always 0, sine 0 is 0, sine pi is also 0. So in both the cases, a cross a is equal to 0 and a cross minus a equal to 0. 0 means I wanted to mean it is a 0 vector. Always remember, cross product returns a vector. So when I say a cross a equal to 0, literally I wanted to mean that a cross a is equal to a 0 vector. A cross minus a equal to 0, what I literally meant is that a cross minus a is a 0 vector. Now let's come to the third point. If theta equal to pi by 2, we know what is the value of sine pi by 2 is 1. So what is the fundamental definition of a cross b? I write, because it is better to write for initial few times, and you please also write along with me in your notebook. So it is a mod a mod b, okay, into sine theta and n cap. Now if we put theta equal to pi by 2, then sine pi by 2 it becomes 1, correct? That becomes 1. So then a cross b become mod a mod b n cap. Now what is literally meant is that here we should write 1 n cap, okay. So that is a third point. Fourth point, very important one. If you recall that I cap, j cap and k cap, these three are the mutually perpendicular unit vectors, okay. I cap represents a unit vector along x axis, j cap represents a unit vector along y axis, and k cap represents the unit vector along z axis. So if I represent here so this is let me draw first and then I will explain, okay. So this is if we consider this as x axis, this is origin, then this becomes the I cap, the unit vector along x axis. Now if we consider this is y axis, then this becomes j cap, that is the unit vector along y axis, and if we consider z, then it becomes k cap, the unit vector along z axis. Now I cap cross I cap, that has to be 0 from this rule. A cap, a vector cross a vector is equal to 0. From the same logic we can say I cap cross I cap equal to 0, j cap cross j cap equal to 0, k cap cross k cap equal to 0. 0 means 0 vector, okay, as you see here 0 vector, okay. Now what will happen? I cap cross j cap, apply the right handed system, I cap cross j cap. If I literally write I cap cross j cap, literally write means if I write from the fundamental definition of cross product, so that will be mod of I cap into mod of j cap into the angle between I cap and j cap, that is 90 degree, that is sine pi by 2, and n cap, that is the unit vector perpendicular to both the vectors I cap and j cap. So what is the value of mod I cap? 1. Value of mod j cap 1. Value of sine pi by 2 1 into n cap. Now that is equal, that becomes n cap. But what is n cap? N cap is the vector perpendicular to both the vectors I cap and j cap, or literally I can say, more precisely I can say, n cap is the unit vector perpendicular to both the vectors I cap and j cap. Now what is the vector perpendicular to the vectors I cap and j cap? that is k cap. So in this context, n cap is nothing but k cap. I hope you got the point. So I cap cross j cap is equal to k cap. Similarly, we will get j cap cross k cap equal to I cap based on the same logic, and k cap cross I cap equal to j cap. Now, if you see in this that circular diagram here, if you just remember one, you can remember the other two. So, you see here this is I cap, then from I to j there is an arrow, then j to k there is an arrow, and then from k to I there is an arrow. That means what? If you replace I by j, j has to be replaced by k and k has to be replaced by I. Here I cap cross j cap equal to k cap. Now, if I replace I by j, that means what is happening here? I by j, and j, then j has to be replaced by k and k has to be replaced by I. Similarly, if j is replaced by k, then automatically k has to be replaced by I and I has to be replaced by j. And to remember it easily, that circular system is explained there. Now, so we are done with the fourth observation. Now, let us come to the fifth observation. In terms of the vector product, the angle between two vectors a and b may be given as sin theta equal to mod of a cross b divided by mod a into mod b. Let me explain you how it comes. Okay. So, if you recall what is a cross a vector, so not a cross, a vector cross b vector, that is equal to mod a into mod b into sin, the digital board is not working properly, into sin theta into n cap. Now, let us take a mod of both the sides. Okay. So, the moment we take a mod of both the sides, so this one mod a, so mod of mod a will be mod a only, mod of mod b only, sin theta, so we will take the mod value, the positive value, and then that mod of the unit vector will be always 1. So, that value will be actually 1. The magnitude of a unit vector is 1. So, then what we will have? We will have sin theta equal to mod of a cross b by mod a into mod b, which is written here, and I hope you got a very clear idea about the fifth observation. Now, all these whatever the observed points you are seeing, that you need to remember to solve relevant questions. So, better to write in your notebook as I instructed earlier. Okay. Now, let us come to the next point, and next point I am going to explain you here. Okay, about the non-commutativity of vector product. Means in general, not in general, actually vector products are not commutative. A cross b is equal to minus b cross a, which makes the conclusion that a cross b is not equal to b cross a. Hence, vector product is not commutative. So, we will see that a cross b is equal to minus b cross a. How? Let us see. Okay. We know what is a cross b from the definition of cross product, that is equal to mod a into mod b into sin theta into n cap, where a, b and n cap form a right-handed system, and theta, that right-handed system means theta is traversed from a to b. Okay, and that is well explained into this diagram. You see that theta is actually traversed from a towards b. Okay, and we have the vector a, we have the vector b, and we have the vector n cap. So, it forms a right-handed system. Okay, right-handed system we discussed in the very beginning of this session. Okay. Now, let us take b cross a. So, b cross a will be what? That mod b into mod a, that means mod a into mod b into sin theta into n1 cap. where B vector, A vector and n1 vector form a right handed system. So, here what is the right handed system? And theta is traversed from B towards A. That means what? Theta is traversed from B towards A. Why? Because this is the vector B, this is the vector A, and in that case, to make the vector B, vector A and n1 to form a right handed system, n1 should be in the direction towards the down. Okay. So, if we assume A and B lie in the plane of the paper, then n1, so this paper, this in fact in this case not paper, you can consider this digital board. So, if we assume the vector A and vector B lie in the digital board, okay, plane of the digital board, then n vector and n1 vector both will be perpendicular to the plane of the paper, but one point. N vector being directed above the paper, that means this is above the paper, and n1 vector directed below the paper, or we know as both are unit vector, one is directed perpendicular to the plane of the vector, okay, means towards upward, and n1 is also perpendicular to the same plane, but direction is downward. Obviously, n1 vector should be equal to minus of n vector. I hope you got a very clear idea, and from that we can conclude the next point. Oh, sorry, what happened? From there, what happened? Just give me a moment. We got it. Now, from there what we can conclude is this point, okay, that that A cross B, let me bring it here. So, remember this, that n1 cap is equal to minus n cap. From that information we can conclude the next important observation. And what is that, dear students, is this one, is that you see that A cross B is equal to mod A mod B sin theta into n cap, that is equal to, now as n cap equal to minus n1 cap, so we put a minus sign here, minus sign mod A mod B sin theta n1 cap, so that is equal to minus B cross A, okay. So, A cross B is equal to minus B cross A. So, in view of this observation, previous observation, what we can say is that we know that I cap cross j cap equal to k cap. So, then j cap cross I cap should be equal to minus k cap. We have observed earlier j cap cross k cap equal to I cap. So, here k cap cross j cap should be equal to minus I cap. Earlier we have observed that k cap cross I cap equal to j cap. So, I cap cross j cap should be equal to minus j cap. So, that is the seventh observation. Now, the next 2 points, 2 observations are important. It is related to finding the area of a triangle for the, and the next one is finding the area of a parallelogram. Let us consider that A and B represent the adjacent sides of a triangle. How come? So, if you look into the adjoining diagram, that AB is a vector, ABC is a triangle by the way, in which AB is represented by a vector called B, for example. So, this is the vector B, okay, and another vector, let me do it in the green color, and AC is a vector, okay, that is represented like this, and it is a vector A, represented by A. Then what we get, A cross B we know, but that I will come after some time. But if we look from the area of the triangle perspective, that area of the triangle is, we know, half into base into altitude. So, area of the triangle, as you see here, dear students, that is equal to half into AB into CD. What is CD? It is a perpendicular drawn from the vertex C to the side AB. So, now if the angle between the vector B and A is theta, we can easily find CD is equal to mod A sin theta. Very easily observed, right? Because we know sin theta is equal to perpendicular by hypotenuse. So, that is equal to CD by AC is equal to sin theta. So, CD is equal to AC sin theta, and AC is nothing but the vector A, but here we are taking the magnitude. So, we take the mod A sin theta. I hope you understood. So, now we apply this value. So, here we apply this value, then what we get, the area of the triangle ABC is equal to half into AB. AB is the vector B into mod A sin theta. So, that means half into mod of A cross B. If you recall, mod of A cross B is nothing but mod A into mod B into sin theta. So, in case any doubt about mod of A cross B, I can explain once more here. So, what is A cross B, dear students? A cross B is equal to mod A into mod B into sin theta into n cap, where n cap is a unit vector perpendicular to both the vectors A and B, or you can say the perpendicular to the plane containing the vectors A and B. Now, if we take a mod of this thing, so what will happen? So, we will take mod of A cross B. Okay, so that will give the mod value of the entire thing, mod of A. So, I can write like this, okay, sin theta and n cap. So, now what we say is that is mod, it is, we can only write mod of A, mod of B. Anyway, sin theta will be positive. Why? Because theta is in between 0 to pi. Okay, in 0 to pi sin theta is positive, and mod of n cap. N cap is what? N cap is a unit vector. So, mod of n cap should be 1. So, that is why it is mod A into mod B into sin theta. So, that is what we have written here, half of mod of A cross B. So, instead of mod B mod A sin theta, we can directly write that is equal to mod of A cross B. I hope you got this point very well. Now, let me come to the next point. Okay. Next point is related to finding the area of a parallelogram when two vectors are represented by the adjacent sides of a parallelogram. Okay. So, let me first bring the note here, and after that I will explain. Okay. So, if A and B represent the adjacent sides of a parallelogram, then its area is given by mod of A cross B. Okay. So, you see this adjoining diagram here. So, we see AD is a vector represented by A, that is AD vector, and then another vector AB is, if you see this vector AB, okay, that is represented by B vector, and angle between the vector A and B is theta. Okay. So, this angle is theta, as you see. So, let me use a different one, green color, this angle is theta. So, now what is the area of the parallelogram? We know area of parallelogram, if you recall, that is equal to AB into DE, where DE is nothing but the length of the perpendicular drawn from the vertex D to the side AB. So, that is DE. So, now AB is equal to mod AB is nothing but the modulus of the vector B, that is already given. And what is DE? That we can find DE is equal to mod A sin theta, the same logic whatever I have explained in the case of a triangle. If you consider the triangle DAE as a right angle triangle in which DE is the perpendicular, then we can find DE is equal to mod A sin theta. Why mod A sin theta? DE is actually equal to AD sin theta. Now AD is equal to mod. So DE actually equal to AD sin theta from the trigonometric ratios formula. So now AD, mod of AD is nothing but the mod of the vector A. So we get this one, DE is equal to mod A sin theta. So now we can we can use the formula here that area of the parallelogram is equal to, as you see here, that mod A mod B sin theta, that is nothing but mod of the vector A cross B. I hope it is absolutely clear. Now dear students, let us move to the two important properties, okay, and these two properties are extremely important to to solve numerical problems, but very fundamental properties. This kind of properties we have used in other mathematical topics. The first one is distributive and second one is a scalar multiplied with a vector. So distributivity of vector over addition. So if we consider A vector, B vector and C vector are three vectors and lambda be a scalar, then the first property tells that A cross B plus C is equal to A cross B plus A cross C. So here you see the cross product is getting distributed over addition of vectors. Second one, lambda into A cross B is equal to lambda A cross B is equal to A cross lambda B, okay, where lambda is a scalar, that means you can consider it as a real number. Okay dear students, so now let us look into the another way of finding the value of A cross B when both the vectors are represented in a component form, okay. So let A and B be two vectors given in the component form. Component form of a vector we have discussed in our earlier sessions, so you can look into our YouTube channel and get a clear idea about it. Let A and B be two vectors given in component form, and what is that? The vector A is written as A1 I cap plus A2 j cap plus A3 k cap, and vector B is represented as B1 I cap plus B2 j cap plus B3 k cap. Then A cross B is equal to is a 3 by 3 determinant, and what is that? The first row is I cap, j cap, k cap. Second row are the three coefficient of I cap, j cap, k cap of the vector A. That means A1, A2, A3, and the third row is the coefficient of I cap, j cap and k cap of the vector B, that is B1, B2, B3, as simple as that. So what is A cross B? A cross B is equal to I cap, j cap, k cap, the first row. Second row is A1, A2, A3. Third row is B1, B2, B3, where the vector A is represented as A1 I cap plus A2 j cap plus A3 k cap, and vector B is represented as B1 I cap plus B2 j cap plus B3 k cap. Okay, I can show you how this actually being derived. Okay, so let me explain you how this is actually derived. And thus to derive that one, we had to take assistance of the rules we have learned about I cap cross I cap, I cap cross j cap. Tongue twister is happening to me. Okay, so what I wanted to mean, dear students, here is that A cross B here. So A is A1 I cap plus A2 j cap plus A3 k cap. B is B1 I cap plus B2 j cap plus B3 k cap. Now we are using the distributive property a1 b1, then I cap cross I cap, a1 b2 I cap cross j cap, a1 b3 I cap cross k cap, a2 b1 j cap cross I cap, a2 b2 j cap cross j cap, a2 b3 j cap cross k cap, a3 b1 k cap cross I cap, a3 b2 k cap cross j cap, a3 b3 k cap cross k cap. Quite simple. After that, what is I cap cross I cap is 0. So this term will be 0. It is no longer be there. J cap cross j cap is 0. So this term will no longer be there. And k cap cross k cap will no longer be there. Okay. So then what we get? a1 b2 I cap cross j cap. Now I cap cross k cap is nothing but minus of k cap cross I cap, because we are maintaining a proper sequence I to j, j to k and k to I. So that's why we written like this in minus form. Similarly, a2 b1 into j cap cross I cap, we can write minus a2 b1 into I cap cross j cap, plus a2 b3 as it is j cap cross I cap, j cap cross k cap, plus a3 b1 k cap cross I cap, whatever it is there, we are writing it here. Now next one is a3 b2 k cap cross j cap, that means minus a3 b2 j cap cross k cap. Okay. So now we know that I cap cross, as I said earlier, but I am mentioning whatever is written here. I cap cross I cap is equal to j cap cross j cap is equal to k cap cross k cap equal to 0, and I cap cross k cap equal to minus k cap cross I cap, this one, j cap cross I cap equal to minus I cap cross j cap, and k cap cross j cap is equal to minus j cap cross k cap. After that, from this step we get this step in a simplified form. Okay. Now after that, what we are writing, that I cap cross j cap equal to k cap. So that's why we are writing, instead of I cap cross j cap, we are writing k cap. That entire explanation is given here. After that, from this step we are getting that this step. Okay, we are taking the I cap common, then j cap common, and then k cap common, and this is represented in a systematic manner by means of this determinant. So I hope you got a very clear idea how this actually derivation in the determinant form came for I a cap cross b cap. Okay, now let's proceed towards a few questions. Okay, few examples let's solve together, and it will clear whatever the understanding we have just discussed. So the first example, what you see, dear students, quite straightforward. Okay, and the example here is that find mod of a cap, mod of a cross. I'm so sorry. Find a vector cross b vector, modulus of that, if both the vectors a and b are represented in the component form. Very simple. That a cross b is equal to determinant I cap j cap k cap, the first row. Second row will be the coefficient of I cap j cap and k cap of the vector a, means this one. You see the coefficient 2 first, so that's why 2 it here, then nothing is there, means it is 1, so 1 is there, and then 3 is there. Similarly, the coefficient of I cap j cap and k cap of the vector b is coming into the third row. Coefficient of I cap is 3, that's why it is written as 3. Coefficient of j cap is 5, that is why it is written as 5, and coefficient of k cap is minus 2, that's why it is written as minus 2. After that, you know how to expand the determinant, and finally we get this, the component form representation of a cross b. but the question is to find the modulus of that one, magnitude. We know square root of this thing, and we get the value of square root of 507. I hope it is very straightforward and we well understood. Now let us go to the next question. Next question, dear students. So let me first place in front of you, and after that I will explain. Okay. So the question here is that find a unit vector. Question is the find a unit vector perpendicular to each of the vectors a plus b and a minus b, where both the vectors a and b are represented in the component form. First we find a plus b and a minus b. Now recall I said earlier that a vector perpendicular to both the, suppose we have a vector p and another vector q, and if we need to find a vector perpendicular to both the vectors p and q, so it is nothing but the vector p cross q. So here we need to find a vector perpendicular to both the vectors a plus b and a minus b, that means this one, and it is nothing but the value of this determinant, where the coefficients are well understood. Coefficients of a plus b and a minus b are written here. Coefficients of a plus b is written in the second row, and coefficients of a minus b are written in the, sorry, let me use a different color. Coefficient of a minus b are written in the third row. Okay. After that we simplified, and after simplification we get, this is the vector representation of a plus b cross a minus b in the component form, and after that we consider this vector as vector c. Then we found the magnitude of the vector c, which is square root of the sum of the squares of the I cap component, j cap component, k cap component, and become 2 root 6. But the question is that we need to find the unit vector. That means this vector c has to be divided by mod of c. So that means minus 1 by root 6 I cap plus 2 by root 6 j cap minus 1 by root 6 k cap. Okay. Now here is a point to be noted. What is the question? Find a unit vector perpendicular to each of the vector a plus b and a minus b. So let me first explain by means of a visual representation. Suppose this is the vector a plus b. Okay. Suppose this is the vector a plus b. Okay. And suppose this is the vector, sorry, suppose this is the vector a minus b. Let us assume, okay, this is the vector a minus b. Now what will be the vector? Let me use a different color, green color. What will be the vector that a perpendicular to both the vectors a plus b and a minus b? One could be something like this. Okay. When, if you remember the right hand system, when the angle is traversed from a minus b to a plus b, correct? Or it could be the perpendicular to both the vectors a plus b and a minus b. It could be this one. Okay, if the angle is actually traversing from a plus b to a minus b. So that is why there could be two perpendicular vectors. Now we need to find the unit vector. So first unit vector we found out here. Now to find the second unit vector, we just need to negate of this thing. Suppose if this is the vector, suppose this is the vector, we get c. Okay, then this vector will be minus c, na? So whenever we find the one unit vector, if we make the negation of all these coefficients of I cap, j cap and k cap, we get the other vector. Okay, so this one, and that is what is explained in the note section. Okay, so I hope you got a very clear idea. Now let me proceed to the next question, and next question is related to finding the area of a triangle. Okay, dear students, so let me place it here. So the first one, first let me read the question. The question here is that find the area of a triangle having the points A having coordinate 1, 1, 1, the B having coordinate 1, 2, 3, and the point C is having coordinate 2, 3, 1. So what we can do is that we can draw the we can construct that triangle. Suppose this is the triangle. Okay, so this is the point A having coordinate 1, 1, 1. This is the point B having coordinates 1, 2, 3, and this is the point C having coordinates 2, 3, 1. Now let us find the vector AB. What is the vector AB? If you recall, it is the I component of the point B minus I component of the point A, that is 1 minus 1 into I cap, which is 0 I cap. So that's why I cap is not mentioned in case of AP. Then if I mark by means of a different color, so j component of the vector B, that is 2, minus j component of the vector A, point A actually, not vector A, point A, that is 2 minus 1 into j cap, that is 1 into j cap. Similarly 3 minus 1, that is 2 k cap. So we get the vector AB. Similarly we get the vector AC. Okay, that is I component of C point minus j component, I component of A point. So 2 minus 1 into I cap, in that way we found it out. 3 minus 1 into j cap plus 1 minus 1 into k cap, that is 0 k cap. That's why there is no k cap component in the vector AC. And we know what is that area of the triangle. Half of AB cross AC we have discussed in one of that previous point observations. So we found the vector AB, found the vector AC, and we can find that AB cross AC by means of that component form, the value of this determinant, as you see it here, and this is the value we got, and then we find the mod of this one, and that is square root of 21. So you should divide by 2 to get the corresponding area of the triangle. I hope you got it very clearly. Now let's come to the next question, and next question is related to area of a parallelogram. Okay, so let me explain it here. So the question here is that find the area of the parallelogram whose adjacent sides are given the vector A, it is 3 I cap plus j cap plus 4 k cap, and B I cap minus j cap plus k cap. So it is directly the vector is given, no vertices is given. If vertices is also given, then you can find the vector the same way we did it for the triangle case. So as these two vectors are the adjacent sides of a parallelogram, so we know the formula to find the area as mod of A cross B. Now as both the vectors A and B are given in component form, it is quite simple to find A cross B by finding the value of this determinant, and this is the we get the vector. Now we need to find the modulus of this vector. We get square root of 42, and we can say square root of 42 is the area, square unit is the area of the corresponding parallelogram. So with this note, let me conclude the session here, dear students, and I will strongly recommend you to log into www.konarkclasses.com and appear for the relevant daily practice problem, that is TPP. With this note, let me conclude. Thank you very much. Bye bye.